What's going on, everyone? In today's video, we're going to be taking a look at standard form, also known as scientific form, and a little bit about what it means, what it looks like, how to do a very quick operation with it, as well as how to go into standard notation as well. It'll be a quick video, but it's also filled with great information. So let's go ahead and dive right in. Now, in standard form, it's also called scientific notation, depending on your textbook or curriculum. We use the base of 10 with an exponent and then have a number out there in front to basically write out really long numbers in a nice compact and shortened method. Now, when we are talking about these terms, A is typically called the coefficient, and A has to be between 1, including 1, or 10, not including 10. What that means is it can be a number, but it has to have one number to the left of the decimal point. So it's only going to have a value in the ones place, and that is very, very important. So it could be 1 point something, it could be 2 point something, 3 point something, but it cannot have more than one number to the left of the decimal place. Now, n is also going to be an integer. That's going to be the power. That's going to be the exponent. And you can see down here that when we are dealing with a volume, we have 2.44 times 10 to the negative 6, 1.5 times 10 to the negative 7, and 2.15 times 10 to the negative 4 as different measurements for our volume. And you can find that if you just plug it into your calculator like I have down here in my last line of problems, it's the same exact solution. All you have to do is plug this into your calculator and you'll get out an answer. And remember what we talked about in a previous video, this E means times 10 to the negative 17. So what that means is 7.869 E to the negative 17 is 7.89 times 10 to the negative 17. Okay, going to mean the same thing. Okay, so that is how you would operate with that, given that you're allowed to use a calculator, as you are in the course that I teach. But just to really drive that point home, that these values need they need to have a number with one value to the left of the decimal point times 10 to the some power. What does that actually look like? So in problem A, when we're given the density of the air at 27 degrees at 1 atm is 0.00161. So what that means is that we want to convert this value here into scientific notation. Well, I do have one value to the left of my decimal place, but remember this value of A, which is right here, has to be between 1 and 10. So I have to move this over 1, 2, 3 decimal places to get it over here, because that way I would have 1.61. That way now it looks a lot nicer. I have a value of 1 and then 0.61. That's looking good. But what is my value for my exponent? Well, remember, I moved it over by 1, 2, 3 units. So what I have to do is I have to make this to the negative 3. Because remember, if it's negative, it moves to the left. The decimal point moves to the left. If it's positive, it moves to a right. Another way I kind of think about it is balancing it out. So this number right here, 0.00161, well, that's smaller than 1.61. So I have to multiply by this negative number to make this number right here go back to being smaller. Makes sense to me. Hopefully it makes sense to you. So for part B, I have this really insanely long number. Okay, so I need to move this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would have 1.97. So that way it satisfies my previous criteria, times 10 to the power of negative 10. Okay, because again, I need that value to be smaller, and that's how I'm going to get that to do that. And how about for problem C? We're doing a light year in terms of the kilometers. So my decimal point isn't mentioned, but it would be right there. Okay, we just don't write it when we have a number greater than 0 like that. So how am I moving over? Well, I'm going to move over 3, 6, 9, 12. I'm going to move over 12, so I'd have 9.46 times 10. So again, 9.46, that is a smaller number than this gigantic value here. So I'm going to multiply by that positive 12 right there. And this would also be kilometers. I should have been using units. My apologies. Grams per cubic meters. So that is how you convert different values into scientific notation. It's what they look like in scientific notation. You can see why we use this, because this right here or this right here, that is so much easier than writing these out, because you even saw me, I kind of struggled with counting them. You got to, it's easy to lose track. So instead of writing out these incredibly long numbers, we just make it a lot shorter. And that's what scientific notation is used for, to make these values a lot easier to work with. So in terms of operations in your calculators, just put times 10 with a certain exponent in. And in terms of converting numbers back and forth, again, you want that one value to the left of the decimal place. And if your original value is bigger, you got to make sure that your exponent is reflecting that. Okay, so hopefully that made some sense, and I'll see you all in the next video.